Hello everyone, welcome to RAJU'S classes. In this chapter, we are going to discuss a fundamental chapter in mathematics, that is nothing but permutations and combinations. This permutation and combination chapter is quite important for all competitive exams, especially if we take ATC exam. This particular chapter is quite important. And moreover, if we see the previous sets of ATC question papers, there is to be many questions from this particular chapter, and especially if we take the 2021-2022 question paper, in all the shifts there were many questions from this chapter. But if we take 2023 question papers, there were no questions from this particular permutations and combination chapter, but still you should not come for a conclusion that this chapter is not quite important. But this chapter is very important for all ATC aspirants. So we are going to discuss this permutations and combinations in detail, as well as we are going to solve the ATC questions, previous sets of ATC questions from this particular chapter. Let us enter into the video now. Hi guys, before entering into this permutation and combination, the concept and problem, we have certain information for you. We have a plan to start our offline ATC classes during July first week. The reason is, whenever ATC notification used to come, most of the time the ATC aspirants, they used to ask us whether is there any offline classes for this or not. This time we have a plan to start, and moreover the seats are limited. Those who are interested in offline ATC coaching, you can directly communicate us. Our contact detail is in the description. And moreover, always there are some ATC aspirants, they need some personal care during the preparation, and that can be given here. And along with the personal care, there are some ATC aspirants, those who need some personal push also, so that they can prepare well and they can go and write the exam very well. So, and from our end also, there can be more success rates. So I request those who are interested, you can directly communicate us. Our contact number is in the description. Now let us discuss in detail the permutation and combinations. Hi guys, before entering into this permutations and combination, we should know the fundamental principle of counting. This is very important, and the fundamental principle of counting says that if there are two events, suppose for example, let us consider event number 1 and event number 2. There are two events now. Event number 1 can occur in m ways and event number 2 can occur in n ways. Okay, therefore the maximum possibilities of event number 1 and 2 will be nothing but m multiplied by n. This is very important. Okay, once again, event number 1 can occur in m ways, event number 2 can occur in n ways. The maximum possible possibilities are, which is m cross n, m multiplied by n. For instance, let us take an example. Suppose here I have got 3 t-shirts, okay, pink color, white color, yellow color. Okay, therefore now there are 3 t-shirts here, and I have 2 pants here of different colors. Okay, so now the maximum possible combination will be nothing but obviously 3 multiplied by 2, which is nothing but 6 possible combinations are there. 6 possible ways that these t-shirts and pants can be combined together. Okay, so my dear friends, this principle of counting is very important before entering into this permutations and combination. Now let us discuss what is permutation, what is combination, what is the basic differences between them. Okay. So now permutations and combination. Okay, what is permutation? What is combination? Permutation is nothing but the number of ways to arrange things in order. This is very important. Arrangement of things in order. That is nothing but permutation. Okay, then what is combination? The number of ways to choose the things. Okay, the number of ways to choose the things. Okay, therefore there is a huge difference between permutation and combination, because in permutation the sequential order is very important. The sequential order or arrangement, okay, these are very important. But when you take combination, order does not matter. Okay, in which order we are choosing, that does not matter, only the combination matters. Okay, therefore permutation is nothing but arrangement of objects or ordering the things in a particular sequence, where the combination is nothing but choosing the things in groups. Okay, this is very important, and without knowing this difference you can't enter into the problem. Okay, so now let us take an example. Suppose if I toss the coin for 3 times, I am tossing the coin for 3 times. Now the HHT permutation is not equal to HTH permutation. Okay, therefore HHT is different and HTH is different, because here the arrangement is 2 heads first, then tail. Here the arrangement is 1 head, 1 tail, again head. Okay, therefore in permutation the arrangements are very important. But here if we take HHT is the same as HTH, because it is merely a grouping of two heads and one tail. Okay, try to understand, my dear friends. Here HHT permutation is not equal to HTH permutation because the arrangements are varying now. But here what happened? HHT or HTH or THH all are of same. The reason is here the maximum grouping is two heads and one tail. Okay, that is the grouping. Okay, try to understand. Here it's applicable for sets. Here it is applicable for group. That is the basic difference between a permutation and combination. Now let us discuss the permutation first and then combination. Okay, in permutation we are going to discuss permutation theory 1, theory 2, theorem 3. There are three theorems are there and we are going to discuss in sequential. Let us discuss the first theorem of permutation. Okay. So according to the first theorem of permutation, okay, suppose if there are n different objects taken R at a time, we have n objects, okay, but we are taking only R at a time. Therefore, the permutation formula is nothing but NPR is equal to, okay, NPR is equal to n factorial divided by n minus R factorial. N factorial divided by n minus R factorial. This is the basic permutation formula, and the theorem 1 says that if there are n objects and we are choosing only R at a time, then the maximum possible permutations are n factorial divided by n minus R factorial. If you want to understand with an example, I will give an example now. Here there are 4 flags. Here there are 4 flags and we are taking only 3 flags with different permutations. What is the the total permutations possible now? Okay, therefore there are 4 flags. Therefore n is equal to 4 here, n is equal to 4 here, and we are taking R at a time. Therefore R equal to 3. Okay, 3 flags are taken now. Okay, the maximum possible permutation, that is nothing but, okay, if you see NPR, which is nothing but 4P3, which is nothing but 4 factorial divided by 4 minus 3 factorial. Okay, what is 4 factorial? That is nothing but 1 multiplied by 2 multiplied by 3 multiplied by 4. Okay, and 4 minus 3 factorial is nothing but 1 factorial. Therefore, now here what happened? There are 6 multiplied by 20. Therefore, there are 24 possible permutations are there when we choose 3 at a time. Okay, so my dear friends, try to understand. This is the basic theorem of permutation. When there are n objects, if we choose 3 at a time, then obviously the NPR will be nothing but n factorial divided by n minus R factorial. This is the fundamental formula. Now let us discuss what is theorem number 2. Okay. Now let us see theorem number 2. Theorem number 2 is very, very important for ATC aspirants because based on this they have already asked many questions. According to this theorem, there are n different objects taken R at a time and the repetition is allowed. This is very, very, very important. Repetition is allowed. Okay, therefore there are n objects, okay, taken R at a time, but the repetition is allowed. Okay, repetition is allowed. So in this case, the number of possible permutations are nothing but n power R. That's it. N power R. Okay, for instance, let us consider how many 3-letter words can be formed with or without meaning from nuts. This is the given word, nuts. Okay, here N is different, U is different, T is different, S is different. There are 4 different letters. Okay, we need to get the permutations in such a way that whether meaning is there or meaning is not there, that doesn't matter, but we need to get the total number of possible permutations. Therefore, here n is equal to 4. We are taking R at a time. Therefore, R at a time is 3 letters are chosen. Okay, 3. R equal to 3. Therefore, the maximum possible permutations are nothing but 4 power 3. Okay, because n power R. Okay, 4 power 3. Therefore, this is nothing but 4 into 4 into 4. Therefore, 4 multiplied by 4, 16 multiplied by 4, 64. Okay, there are 64 possible permutations are there. Okay, my dear friends, the repetition is allowed, repetition is not allowed. Based on this, already there are questions from ATC, question paper set. Therefore, you need to be little bit thorough with this concept. Okay, now let us see what is theorem number 3. So, if you see theorem number 3, this is also quite important because in ATC question paper, there were questions from this particular theorem also. Let us see what is that theorem. This theorem says that there are n objects, okay, there are n objects out of which P1 objects are of same kind, okay, and P2 objects are a different kind, and P3 objects are a different kind, something like that, okay. Therefore, now what happened, the total possible permutations will be nothing but n factorial divided by the first kind factorial, the second kind factorial. That means there are n objects, n factorial divided by P1 is the same kind of object, therefore P1 factorial, P2 is another same kind of factorial, sorry, objects, therefore P2 factorial, and so on. So, my dear friends, there are n objects now. Out of n objects, P1 objects are of same kind, something like, blue balls, red balls, something like that, okay. Therefore, now what happens, let us see the example now. Suppose if we consider a word Allahabad, okay, the maximum possible permutations are, okay, we know that in Allahabad, A is repeated for 4 times. A is repeated for A, 4 times. And L is repeated for, okay, L is repeated for 2 times. A, L. Therefore, L is repeated for 2 times. So, my dear friends, A is repeated for 4 times and L is repeated for 2 times. And we know that in Allahabad, there are 9 letters. N is equal to 9. Therefore, 9 factorial, n factorial divided by same kind, A is of same kind, L is of same kind. Therefore, 4 factorial multiplied by 2 factorial. 4 factorial multiplied by 2 factorial. So, here what happens? Okay, 9 factorial, 9 multiplied by 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4, 3, 2, 1. I can write 4 factorial divided by 4 factorial into 2 factorial is 2. Therefore, 4 factorial will be cancelled out. Okay, the entire thing divided by 2 will give you, okay, 7560. Okay, so my dear friends, so this particular theorem is very, very important for all ATC aspirants because based on this already there have been some questions. Now let us see what is the basic formula for calculating the combinations, as well as let us find out how to identify the permutation problem and combination problem now. So now these are the keywords to identify whether the problem is belonging to the permutation or the problem is belonging to combination. For example, if you get the word something like, arranged, lined up, made, sequentially ordered, if you get such words, these are responsible for permutations. Okay. Similarly, if you get words something like selected, chosen, drawn, taken, grouped, and these words are, okay, responsible for combination. But you should not blindly take into consideration, but better to identify these keywords so that we can come to a conclusion whether they are asking about the permutation or combination. So these keywords are very, very important. Suppose if we consider n objects taken or at a time, okay, or are grouped together, now the combination formula NCR will be nothing but n factorial divided by r factorial multiplied by n minus r factorial. This is the formula for combination. N factorial divided by r factorial multiplied by n minus r factorial. So my dear friends, this is the fundamental concept of permutation and combination. Based on this, let us see how they have asked the problem for this ATC exam, especially from permutations and combination. Let us discuss one by one now. Okay. So if we take the first question, this is the question from ATC 2021 shift 2. Okay. So the question is very simple. NP4 divided by n minus 1 permutation of 4 is equal to 5 by 3. What is the value of n when n is greater than 4? Therefore, 14, 10, 5 by 3, 33. Which answer is correct? Okay. And this is a fundamental question because if we know the NP4 formula, the permutation formula, suppose NPR formula, we know that n factorial divided by n minus r factorial. This is the formula. Okay. Therefore, this NP4 can be written as n factorial divided by n minus 4 factorial. The whole divided by n minus 1 p4. Therefore, n minus 1 factorial divided by n minus 1 minus 4. Therefore, n minus 5 factorial is equal to 5 by 3. Okay. Therefore, now what happens? N factorial divided by n minus 4 factorial. This n factorial divided by n minus 4 factorial, okay, multiplied by this can go up, okay, n minus 5 factorial divided by n minus 1 factorial equal to 5 by 3. Okay, so now the thing is, suppose if we take 9 factorial, this 9 factorial can be written as 9 into 8 factorial. This 8 factorial can be written as 8 into 7 factorial. Therefore, n factorial can be written as n multiplied by n minus 1 factorial. Okay, this n factorial can be written as n multiplied by n minus 1 factorial. Similarly, n minus 4 factorial can be written as n minus 4 multiplied by n minus 5 factorial, the previous factorial. Okay, therefore, here n minus 5 factorial divided by n minus 1 factorial equal to 5 by 3. Therefore, n minus 5 factorial, n minus 5 factorial will be cancelled out. N minus 1 factorial, n minus 1 factorial will be cancelled out. Therefore, n divided by n minus 4 is equal to 5 by 3. If we go with the cross multiplication, okay, 3n is equal to 5n minus 20. Therefore, 2n is equal to 20. Therefore, n is equal to 10 is the correct answer. N is equal to 10 is the correct. Here, option B is correct. Okay, so my dear friends, if you know the fundamental formula of permutation, this problem would have been solved, because you need to solve within 60 seconds. Within a minute you need to solve. Therefore, this problem is quite easy, as well as you need to apply just the fundamental concept. That's it. Okay, now let us see what is the next question. So the next question is from the same shift, 2021 question paper, shift 2. But this particular question is from permutations and combination as well as probability. You need to apply both the concept. Okay, and this problem is involving both permutations and combinations along with the probability. Okay, it will take a little bit of time, but you need to solve it within 60 seconds, that is 1 minute. Let us see how to solve this. Let us see the question first. In a dog race, okay, there are 5 dogs A, B, C, D. We have 5 dogs. Okay, A, B, C, D, E. Out of these 5 dogs, 3 dogs are taken, okay, to finish the, okay, but A, B, C are the first to finish. Therefore, A, B, C, these 3 dogs to be the first to finish. Therefore, in first 3 places, D and E should not come. But at the same time, A, B, C are first to finish in any order. In any order. So, we need to go for a combination of A, B, C. Okay. Let us see what is the probability. Okay. The probability of A, B, C are the first to finish in any order. That is the question. Okay. So, total number of permutations first we need to find out. The total number of permutations will be nothing but the total sample space. Okay. The total number of permutation here n is equal to 5, r equal to 3. Therefore, NPR, that is 5p3 will be nothing but 5 factorial divided by 5 minus 3 factorial. That is 120 divided by 5 minus 3 factorial, 2 factorial 2. Therefore, there are 60, okay, sample space. S equal to 60 sample space. N of S equal to 60. Out of the 60 permutations, first 3 should be A, B, C. So, what are the possible combinations? Because any order they have said. That therefore, suppose it can be A, B, C, or it is the BAC, or it can be BCA, okay, and it can be something like BCA, okay, or BAC, or CBA, okay. So, like that there are 6 combinations possible, because we have 3 dogs in the first, okay. Therefore, ABC, BCA, or BAC, or CBA, okay, like this combination n is equal to 3. But R can be 0 in any order, okay, in any order. Therefore, now what happened? Here 3 factorial is the possible combination, that is nothing but 6 is the answer, okay. Therefore, the total probability will be nothing but 6 is the possible combinations of ABC in first 3 and out of sample space 60 total permutation. Therefore 6 by 60 is the answer, that is 1 by 10 is the answer. Therefore 1 by 10, option A is correct. Option A is correct. Okay, my dear friends, this is the problem involving a combination of permutation combination as well as probability. Okay, therefore everything is getting involved, so you need to solve a little bit faster. Okay, this particular question. Now let us see what is the next question. This is also 2021 shift 2 question paper only. Okay, the question is very simple, I guess. What will be the total number of permutations of n different things taken or at a time where repetition allowed? That is a straight formula. Okay, based on theorem 3. Okay, or theorem 2, I guess. Okay, therefore now what happened? There are n objects are taken at a time. Okay, and repetition is allowed. Repetition is allowed. Okay, when repetition is allowed, we know that the formula is very simple, n power r. N power r. Okay, we have seen that, no, nuts, nuts. Okay, what are the maximum possibilities of choosing 3 letters where the repetition is allowed? Therefore, if I choose 3 letters when repetition is allowed, okay, it can be of nuts, of anything. Therefore 4 we are getting here, and again, okay, 4, again 4. Okay, in 3 letters, okay, the all possible repetitions are allowed. Therefore 4 multiplied by 4 multiplied by 4. Okay, therefore that is nothing but 64. Okay, it's the same way here, n power r is the correct answer. N power r is the correct answer. So my dear friends, I hope that you would have understood this, because this is a straight theorem formula and directly you can take the answer. It's the easiest question in that particular shift. Okay, now let us see what is the next question. So friends, the next question is from the same shift, okay, 2021 question paper. Okay, so now as I said earlier, from this particular question paper there were many questions from permutations and combinations. Okay, so here what they have given is NC9 is equal to NC8. Here you should know some logic and shortcut. Okay, suppose NCR1 is equal to NCR2, then your n will be equal to R1 plus R2. R1 plus R2. Similarly, here they have given NC9 is equal to NC8. Therefore, n is nothing but your R1 9 plus R2 8. Therefore, 17. Therefore, 17 C17, which is nothing but 1. NCN is 1. Okay. Therefore, answer is 1. That is the correct answer. Okay. This you can solve even within some 10 seconds. Okay, because they have given NC9 is equal to NC8. Therefore, n should be is equal to 9 plus 8. Therefore, 17. The question is, what is NC17? Therefore, 17C17. Therefore, 17C17 is equal to 1. NCN is equal to 1. Okay, so this problem is very, very simple. Now, let us see the next question. So, my dear friends, like this, there are many questions from that particular 2021 question paper set itself. I will be solving in the next video. Okay, so this particular chapter is very, very important. So I request all ATC aspirants to be very much thorough with this. Anyway, thanks for watching this video. Those who are not subscribed to the channel, please subscribe it and also press the like button so that it will be encouraging us. Okay, thanks for watching once again.